Hey guys, welcome back to ViewSource. This is Milan, your host, and today we're going to follow up on the previous post where we had a quick introduction to DevOps. We've discussed what it was and what problems it was trying to solve, but now I'd like to go a little bit further and focus specifically on this section here, continuous integration. If you understand Serbian, feel free to quickly go over it again if you wish. Basically, my goal for today's lesson is to show you how to set up continuous integration for your projects using a handful of tools, such as Jenkins primarily, but also Composer, PHP Unit, Git, Bitbucket, and maybe something else. We'll see down the line. Okay, so before we start, let me show you at a very high level the flow we are going to develop. Here we have a single developer or a team of developers. Team size doesn't really matter. But the idea is that someone is working on the project and pushing the latest changes to the version-controlled server. In our case, it's Atlassian's Bitbucket because they allow us to create private repos for free. So whenever a developer pushes his code to Bitbucket repo, we'll configure it to immediately trigger a build on our Jenkins server. If you're not familiar with Jenkins, think of it as a software which you install on a server to do some heavy lifting for you, such as pulling the latest code, installing dependencies, running tests, and finally deploying the code on your environments, of course only in case when everything passed with no errors. Otherwise, it would stop the process and let you know exactly what went wrong, so you could go back and fix. And the last component is the application server or servers, depending on how big your project is. This is where Jenkins deploys highly tested code for us. And that's it. Let's start now by creating a new project. I thought about simulating a very basic password validator class because many times we are more interested in learning just a workflow rather than in building some complex applications. That's why I'll focus on the things like how would you go about setting all this stuff, as we said, Jenkins for continuous integration, then Composer for dependency management and auto-loading, PHP Unit for testing, Git and Bitbucket for source versioning. There are a lot of tricky things that might be set wrong. Of course, to follow along, make sure you have installed Composer. It's a very simple process, just go to official website and read short instructions for your system. I can simply verify that Composer is running for me by typing Composer in command line. You see, it outputs me a list of available options, which is good. Alright, once you have Composer installed, you have access to a huge amount of packages created by community, including PHP Unit, which we'll use for running our tests. So if I go to packagist.org, a single place where all Composer packages are hosted, and search for PHP Unit, sure enough, it's available. So to get us started, I'll create a new repository in Bitbucket. I assume you already have your account, so we should be all on board here. Let's give it a name of VSCI, short of ViewSource Continuous Integration, and everything else is already set as it should be. It's private, it's Git. I don't really care about issue tracking and wiki for this project, so we can move forward. Alright, it's created for us and we got instructions for the next steps. Since I'm already into my project folder, I'll do git init and copy the second line to add remote repo. Okay, that was simple. Now I'll add the project to my editor. And the very first file I'm going to create is composer.json. This is where we define dependencies for the project. I only need PHP Unit, so within here I can type require dev block. This is for all dependencies that shouldn't be installed on production, and if you're not sure what the latest stable version of PHP Unit is, you can always go back to packages to check. Seems like it's 4.3.4. So let's copy this and paste into our required dev block. That's all we have to do. Now we can go back to command line and run composer install. The simple command is going to download PHP unit and all its dependencies into vendor folder for us, because by default Composer install command assumes you want to include dev dependencies. This might be a little bit slow, so let's cut this down and continue once it's completed. It's done. You can see that I got vendor directory with PHP unit and some other packages that PHP unit depends on. Here we see Composer log file, which is also important because after installing dependencies, Composer writes the list of the exact versions it installed into this file, so that anyone who sets up the project, whether it's another developer or Jenkins machine, will download the exact same version of the dependencies. That's why we'll put this whole vendor folder into gitignore, because there's no need to add all of that code to the repository. It's enough to have Composer.json and Composer log only and let Composer to do its magic. I'll create a new file, save it as gitignore, and quickly add vendor folder in it. Okay, we are good and ready for the very first and initial commit. If we check git status, we see 3 files are untracked, there's no vendor folder, so we can add all of them and commit. Git add all, git commit, I'll put the message app in it, and here we go. Okay, good. Now let's quickly create some simple code to work with. As we said, it's going to be incredibly simple, just a single validate password class, so let's create a tests folder first, following the rules of TDD, and a new file in it. We'll call it validate password test.php. So let's see how might we do this. We'll say class validate password test, and it's going to extend PHP unit framework test case. So let's begin with a very simple bit of a behavior. This class should have, for example, functionality to validate the length of the password, so public function test valid length. We're testing validate password class, so let's assume it exists so we can create a new instance here. So valpass equals new validate password. Again, this still doesn't exist, but we'll fix it shortly. And then we have access to a large amount of PHP unit functions, so this assert false, and we expect valid length, this is method in our validator class, to return false when we provide 4 characters password, because apparently it's too short. Now we can implement many tests here, but it's not what we want to focus on, let's rather keep it very simple. One thing that I do want to call out though, as you see, the first line here creates validate password class instance. It's okay in our case, because we have only one test, but if you don't want to instantiate it over and over in every test you write, you can leverage PHP unit's fixtures and specifically a method called setup. I encourage you to visit PHP documentation and have a read. Alright, as you might imagine, this is not quite ready yet, but let's try to run PHP unit. I'll go back to my terminal and type dot, this means start from the current directory, and then vendor bin PHP unit, because this is where PHP unit binary lives. And of course, we need to specify what to test, so as a second argument, I'll pass dot tests validate password test.php. Alright, it's telling us it tried to run the test, but it couldn't find validate password class. So let's see how might we go about fixing that. Within our project, I'll create source folder first and validate password.php file. So class validate password will say that password length should be between 6 and 20 characters, so we need a constant min length to be 6 and another constant max length to be 20. Okay, now we'll say public function valid length. It's going to accept a password, and we should only check whether or not it passes required length interval. First, let's say password length in a variable. Pass length equals string length, and as an argument it accepts password. And then we can easily do a check. When we try now, it still can't find validate password class. And of course it can't. As you probably guess, we created a class, but we haven't referenced it inside validate password test. There's nothing signaling that we're going to autoload the class, so it still can't find it. So we can require it within here at the top, but you know what? That would be a bit of dated practice. Instead, we'll take advantage of autoloading using Composer, because it works out of the box. You don't need to do absolutely nothing, it's already there. That's another nice feature of Composer. So the only thing we need to update is Composer JSON file, because this is where we can specify what to autoload. Are we doing PSRO autoload or PSR4 or maybe class maps? Personally, I got used to PSRO, although PSR4 might be a better choice these days. Nonetheless, I think everything will do for us in this silly example. So we'll need to create autoload block and tell Composer to follow PSRO standard. And the object that comes after represents namespace. I leave it empty, our code lives in the global namespace, and this is the physical path where our code lives, which is source. The very last step is to run Composer dump autoload, which will regenerate the list of all classes that can be required by our project. Alright, we should be all set by now. If we run our test, sure enough, it's able to find the class it needs, and our test is passing. Let me commit latest changes. I'll do git status. I'll add all. And finally, I'll do git commit adds validate password class and test. And finally, let's push it to remote repo, because from now on we'll mostly work in the cloud. For our hosting needs, we'll turn to DigitalOcean, so both Jenkins instance and our application will be hosted on DigitalOcean. Now, when you first go to digitalocean.com, you'll see a page similar to this one. DigitalOcean is a cloud hosting, much simpler than Amazon Web Services, for example. You start up your own instance, your own droplet as they call it, and droplet starts at $5 per month, or if you prefer, $0.007 per hour. If you have any question about pricing, head over to their pricing page. You should be able to find useful information. Alright, let's go ahead. What you're going to do is to click on sign up button. You'll be asked to fill in your billing information. It's a really simple process, and once you're fully signed in, you won't have any droplets created. It will guide you through the process. You'll be given a create button, and once you go ahead and click on create button, you'll be able to enter your host name. This is going to be our application server, so let me call it simply main app. Next, you can select the size you need. Typically people start off with one CPU, 20 GB SSD drive. Usually this is enough to run pretty simple website, and of course you can scale up at any time. So I'm going to select the most basic size. Then we are asked to select the region which is closest to us. You see they offer us 5 different locations. Closest to me is Amsterdam, so let's choose that one. Next, we have available options to choose from, but I'm going straight to image selections. They have 5 different choices here. All of them are Unix based. I'll select the latest Ubuntu 64-bit. Now, because we are going to use PHP, I'll make sure to go to Applications tab and select LAMP on Ubuntu. That's all there is to it. I can go ahead and click on Create Droplet. Usually it takes just a minute. I'm going to pause this video so you don't need to wait for the droplet to create itself, and restart the session once the droplet is created. Alright, so the droplet finished up creating itself. I was redirected to Droplet panel, where I have some information about it, then some options to manage the instance, but let's move forward and log into the server with SSH. Here's the droplet's IP address. DigitalOcean sent me an email with the password for the root user. I have pasted it in my editor, so let's use PuTTY for Windows for SSH access. So log in as root, password, copy the password that DigitalOcean sent. Now, once you get into, it will immediately prompt you to change the password for the root user. So let me go ahead and first right-click to paste the old password from the clipboard, and then I'll enter my new password. I'll retype it, and nice! I'm logged in into my Ubuntu droplet here. I can type clear to clear this view up, and then I can begin navigating through my droplet. So the first thing I'd like to do is to go directly to var, and then web folder, and there's actually HTML folder within here. This is where you typically put your web application files. Okay, let's get our app onto the machine. Thanks to DigitalOcean's application images, our machine comes with LAMP, so we don't need to worry about PHP and Apache installation, but we still need to install Git, which should be as simple as apt get install git. Once Git is installed, we can use it to get our app from Bitbucket. We only need to copy the clone URL from the project's Bitbucket page and then run this in our server. It's asking me for password. Alright, that was fast enough. We see it got cloned. I'll do ls-la. Now, before we can dig into Composer and installing our dependencies, of course, we need to install Composer. I prepared the command. We can see here it's just a matter of copying and pasting this to the terminal window. Now you see that it installed composer.far file. Think of this as PHP archive file. So if we want to run Composer, we can type php composer.far and we get the output. However, it's always a good practice to enable Composer globally. To do that, all we need to do is to move this file to bin directory. So I'm going to move composer.far to my local bin directory, which is user, local, bin, and composer. And that's it. So now I should be able to type only Composer and get the exact same output. Now to demonstrate again how to download all the dependencies, we should first cd into our project and then only type composer install, but this time with no dev option. Now you might be asking yourself, why do we need this no dev option? And the reason for this is, well, this is the application server. We don't need to run tests here. Instead, it's Jenkins' responsibility to run all the tests and deploy highly tested code to the application server. So when we run this command, we see there was nothing new to install, but still it generated autoload file, which will bring autoloading over to us. Very simple and useful. Alright, we can move forward, so we'll start with the installation process for Jenkins. The first step, of course, would be to set up another DigitalOcean droplet for Jenkins. We'll repeat the process from the previous time, so I'll go ahead, switch to DigitalOcean tab, and click on Create a Droplet. Again, bunch of options. I'm going to call this one Jenkins. Choose the cheapest plan, select Amsterdam. Image is Ubuntu, which is fine, and let's make sure that we have LAMP set up by default. That's all. I'll give it a moment or so and it will install. Alright, here you can see that I have my Jenkins VPS up and running. DigitalOcean has sent me credentials for SSH, so let's go ahead and log into it. I'll start another instance of my PuTTY, paste the host here, okay, username root, I'll copy my password and right-click into PuTTY. Again, it's asking us to change default password, so this is the old password. I'm going to right-click again, and I'll type my new password twice. And we're in our Jenkins server. Excellent! Now, before we can use Jenkins, we need, of course, to install it. We're going to get everything set up from scratch. It should only take a handful of minutes. Thankfully, DigitalOcean has published this nice guideline, so we only need to copy these 4 commands into our command line. Usually we install stuff on Debian-based systems using apt-get, but we need to add a new repository first to make it able to pull Jenkins installation. So it's done in those 2 commands. The first step is to add Jenkins key. Then we'll update our source list and include Jenkins repo. Now, before we can actually run Jenkins installer, we need to do apt-get update. And as the very last step, we can type apt-get install Jenkins. That's all there is to it. As always, I'll take advantage of screencasting magic, pause the video now and continue once it gets installed. Okay, it's finished. By default, Jenkins listens on port 8080, so if I switch to my browser and paste the IP, port 8080, yes, we see Jenkins welcome screen. Apparently, it's completely insecure and everyone on the web can access it, but it's not concerning in this case at all. I'll kill the server as soon as I'm done with this video. For real projects though, I highly recommend you to go to Manage Jenkins and enable user authentication. It will ask you to create a user, and once you are done, it will prompt you with login screen before you can manage Jenkins. I'll leave it to you. Let's focus on the things that really matters. We know the purpose of Jenkins is to pull our project from Bitbucket and run its tests, so we need to install Git and Composer, but also we are going to need Bitbucket's plugin for Jenkins. So let's add missing pieces quickly. I'll move very fast since we've already covered it while setting up our app server. So to install Git, I'll quickly type apt-get install Git. For Composer, it's 2 steps. And done. The second part is to install Bitbucket plugin for Jenkins. In order to do that, I'll go to Manage Jenkins, then Manage Plugins, go to Available tab. Sometimes when you install Jenkins, you will notice that the list of available plugins is empty. If that is the case, from Advanced tab on the Manage Plugins page, click on Check Now to forcefully check for the new updates. Once that is done, you should see the list of plugins. In my case though, everything is fine. I see the list. Let me search for Bitbucket. Now click on Download Now and Install after restart. This will take some time, so let's fast forward. Now we're ready to create our first job in Jenkins that connects to our Bitbucket project, does automate builds and displays some results. I'll click on this link here to get us started. Our job will build application server, so let's give it a name of vsci-build, and I'll select freestyle project. In most cases you'll end up with this option. Great! As you see, we have project name, description that help us explain what's the project about. We see a bunch of other parameters. The important one to fill out is this section called Source Code Management. This is important for Jenkins to know how to communicate with my source code repository. You see we have here some choices: CVS, Git, Subversion. Of course we have none. Sometimes we don't need to have our job communicate with our source code repos. In this case we do, so I'll select Git and I'll provide SSH URL to my project. Now this part here, branches to build, is interesting. That option is provided by Bitbucket plugin we have installed, and because it's so useful and important at the end, I'd like to break it down a bit. You need to understand that Bitbucket will ping Jenkins server on every single push. Whether it's on master branch or developer or any feature branch, you can't really avoid it. That's how Bitbucket's post hook works. That means every single time a developer pushes his code, a request comes to our Jenkins server, which will trigger the build. If you think about it, it's pretty useless and overwhelming, right? We certainly don't want to do a build when someone commits his work to a feature branch. But with this plugin installed, we'll have it parse Bitbucket's post request for us and run the build only when it's dealing with master branch. Technically, that happens when you merge any of our feature branch into master. Next section we care about is build triggers. I'll go ahead and check build when a change is pushed to Bitbucket. This option is also given by Bitbucket plugin. Hopefully it makes sense why it was necessary to install it. This won't work unless we set a post hook on Bitbucket repository too. We'll do it in a minute. And finally, this is where you add your build steps. Personally, I use execute shell option in almost every job I create. Basically, that instructs Jenkins to execute shell commands for me, which is pretty handy. So, what do we want to execute? Well, at the moment, Bitbucket plugin will pull the latest code for us. So, next thing you would do in terminal is run composer install and run all tests. So, I'll go ahead and write. This is where our PHP unit executable is, and this is a folder where our tests live. Now this still won't work. First, we already said that we need to instruct Bitbucket to send a post request to Jenkins on every push, but you can also see it can't connect to Bitbucket. And of course that's the case, because our repo is set to be private. When Jenkins tries to clone the repo via SSH, it doesn't know how to identify itself. So we need to set SSH key pair, and let's do it first. I'll go ahead and switch to my terminal. When Jenkins installs, it creates a new user called Jenkins, of course. It executes all commands with the user, so we need to generate our key with the Jenkins user. So let's switch to it. I'll do su Jenkins. Now I'll navigate to home directory, so let's look and see what's in the home directory. Usually a server keeps its key pairs into .ssh folder. Apparently that one doesn't exist at the moment, but let's see how might we solve that. If we just type ssh-keygen, we are making key pair, but it will be DSA by default. RSA is actually a little bit faster, so let's change the type and set it RSA. It's generating key pairing, two separate files that link to each other. This is where it's going to be saved, which is fine. I'll hit enter. Now it's asking for passphrase, which will leave empty by hitting enter, since the whole point of this is to avoid passwords, especially because we'll have automated jobs which have to be authenticated, but they can't really type passwords. I'll type enter again, and it's done. If we do ls-la, we see .ssh folder, and inside of it both private and public keys. Now what we need to do is to copy the content of this public key and paste it into Bitbucket. So let's take a look at the public key. I'll type cat id-rsa and copy everything from here. In PuTTY you can copy by pressing enter. I need to switch back to my repo, and then I'll go to settings, deployment keys, and as you might imagine, add key. The label field is to help you remember what this key was about. The key is important, so let's paste everything from clipboard. Okay, we should be all set. I'll go ahead and press add key. Since we are here, let me also register a post hook for this repo. I'll go to Hooks tab and search for post. Okay. The URL needs to be the domain of our Jenkins server. I'll grab IP since we don't have domain. This is something I found in Bitbucket plugin documentation. So with this setting in place, when a user makes a push against a repository, Bitbucket makes a post request to the URL we provide here. The body of post request contains information about the repository, branch, a list of recent commits, the user that made the push, etc. That's how the plugin is able to decide whether or not to run the build. It simply checks the branch, and if it matches with master, it's going to proceed. Okay, we're almost done. There's only one very last thing we need to fix. You see that annoying error still shows up. Well, the reason for this lays in the way how SSH protocol works. When Jenkins tries to establish SSH connection to Bitbucket, it needs to know it's connecting to right SSH server. That's why we need to run this command, which will basically update known hosts with Bitbucket's public key. I'll type yes, I'm sure everything is fine and safe, and that's it. Now if we wait for some time, this message will go away, but we can simply save the project and go back to it. And sure enough, no errors so far. If we run the build at this time, it won't fail, but let's think what's this job going to do. It will pull the latest code, it's going to run composer install and run unit tests, and that's all nice. We're testing our changes, but what about deploying these changes to the app server? Well, you remember our flow from the beginning? If these two commands pass with no errors, why don't we simply copy all application files over to our application server? We'll use rsync, a very handy command which offers a large number of options that control every aspect of this behavior. We'll pass verbose, recursive, this Z stands for compressing the data, H for human readable output, and finally E flag to pass options to SSH command. If we provide this, we're basically instructing our Jenkins server to always add new host keys to the known hosts file. So we're bypassing the exact same situation we had with Jenkins at Bitbucket, and this is a well-known way. You might also imagine that we don't want to transfer vendor folder since we use Composer. So that's why we want to make sure we exclude it. Last two parameters are source folder for the files that are going to be transferred, and of course destination folder. As a source folder, I'll put only a dot, which translates to the current job folder, and for destination folder, I'll put it needs to connect as root at IP address of the server, followed by the path to our application, which is var, web, HTML, and VSCI at the end. At this point, it synchronized source and destination. Now what we need Jenkins to do next is to SSH to the application server, then cd into application directory and run composer install with no dev flag, which skip installing packages listed in required dev sections. Whenever you need to run multiple commands within one SSH session, the cleanest way is to surround it with here script, like this. This is so-called here script. And okay, I think we should be all set on Jenkins part. Now, the very last thing we need to do is to create a file called authorized keys on the main app server and paste the Jenkins server public key. That way, whenever it tries to SSH into the app server will allow it since it has its public key in authorized keys file. I have my Jenkins public key here. Again, it's the same one I put into Bitbucket, and I'll need to switch back to my main app terminal. I'm logged in as root here, so I can type cd tilde, which will basically open root's home directory. Within here, I can go to .ssh folder and do ls-la. Since authorized keys file is already there, I can edit it, use it nano, and I can simply paste the key and save the file. And that's it. We had a couple of things to configure, but hopefully everything is working as we would expect. I'll switch to Jenkins, and for the very first time, let me save the configuration first, and then I'll manually run the build just to see how it works. So to do that, I can simply click on build, But before that, let me enable auto refresh at the upper right corner. You see it's done. This blue circle tells us the job has finished successfully. Typically it's red when something goes wrong. Now if you're interested to see the entire output from the console, you can click on Console Output. You see the first part is related to fetching the code from our repo. It's done by Bitbucket plugin. Next we see logs coming from PHP unit, so everything fine on that side, one test passed. And finally we see rsync output. It's transferring all Git files, which is interesting. I completely forgot to exclude them. However, I'm not sure whether it's okay to leave them or exclude them. What would be the best practice? Honestly, I don't see the reason why would we need Git files on the application server. On the other hand though, we are cloning the whole repo, so it makes sense to include them as well. For now, let's live with these settings, and I'll update below if I find a better way. And this last bit here is from Jenkins, when it SSH'd into the app server. At the very end, we see that Jenkins finished with success. Excellent. To finish up with this lesson, let's see what will happen with two edge cases. The first scenario we're interested in is to see what will happen if we make a commit in a feature branch and not on master. Jenkins shouldn't start a build in that case. The second interesting scenario would be to commit the test which fails on master branch. In that case though, Jenkins should run the build, but since our test is failing, it should not deploy anything to our app server. Let's start with the first one. If we do git branch, it says I'm on the master branch. Let's create a new test branch and switch to it. Okay, it created a branch and switched to it. What I'm going to do is to add a few empty lines into this validate password test class. And now if I run git status, it's modified, so let's commit and push this branch to remote. Git commit -am adds feature x, git push origin test. Okay, nice. We see a new branch was pushed to remote, so let's quickly go to Jenkins and check if push triggered the build. I'll click on our job and we can verify it indeed didn't run the build. Let's now try the second case. I'm still working with the same file, so let's add a valid length for password. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. This will obviously pass, but we're expecting false in this test. I'll commit this, git commit -am adds failing test, just for fun. Git push origin test. Okay, it went to remote, which is fine. At this point we know it's not triggering the build, but let's merge this feature work into master. I'll do git checkout master, and then I'll do git merge test branch with -noff. I need to pass no fast forwarding option, and of course I'll do git push origin master. Okay, nice. We'll wait a couple of seconds. And you see the build has started. Let's give it a moment. Sure enough, it's red. If we click on build information, you see it's very clear. Validate password test, test valid length failed, asserting that true is false. And at the end finished with failure, which is all good. Okay, that will do it for this lesson. This project will be up on Bitbucket. I'll unlock it for the public, so have a look through it, see if you can extend it, try out some different approaches. For example, try to set up Jenkins running this job periodically and not on every push. There's a lot of options. The important thing though is that you dig in and experiment with it. If you need DigitalOcean account, you can use this referral link and earn $10 for free. Or if you're a student, there's a nice promo pack at this time coming from GitHub, which will give you $100 credit. Thanks for your time. My name is Milan, and please reach out to me if you have some comments on this. See ya!